You can see a formula now which we already translated to CNF in one of our previous exercises. Now we want to do the same, but this time we want to use the optimized algorithm for that. Here you can see this so-called optimized algorithm. It consists of specific steps. So for instance, in the first place, we have to try to eliminate all the XORs and equivalences and implications and so on. So let's run this algorithm. If you look at the formula, you can see that it contains no XORs, no equivalences, but it definitely contains implications. This is what I'm going to do. I'm going to eliminate this single implication by negating its left-hand side, and then I just need to replace the implication by disjunction. Yeah. Okay. What else can we do? What else can we apply in the first step? Well, we definitely need to move negations as inward as possible by applying the De Morgan laws. If we look closely, we can see a negation here, which can be moved inward. It can be moved behind this quantifier, and that's it. So this is what I'm going to do. I'm going to move the negation here, and of course, meanwhile, the universal quantifier changed to an existential one. Okay, the first step is done. There is no other, we don't have any other duty in step one. So let's continue with step two. This is about transforming the formula to clean form. Clean form means that quantifiers must not share variable names, and actually this holds. All the three quantifiers bind different variables, but there is another restriction coming from the clean form, and this has something to do with free variables. This restriction says that no quantifier can bind a variable which appears as a free variable somewhere in the formula. And actually, if you look closely, this causes a problem because this existential quantifier exists x binds x, and x appears as a free variable in Ryx. What can we do? Well, of course, we can and we should rename the bound variable to something else. Let's say I'm renaming this variable, this bound variable to v. Okay, so step two is done. Let's run step three. It's about prenexing. As the algorithm, as the description says, we just need to move the quantifiers in front by keeping their order. Actually, this is what we have to do. We grab all of the quantifiers and move them in front, and this is really easy. We don't have to think, we don't have to do anything, just enumerating all the quantifiers in their order of their appearance. So now we have three quantifiers in front: x is y, x is v for all z, and in their scope we just keep everything else. So we keep not r v y or r y x and r z z, and that's it. And this is really cool. We have a prenex formula. Okay, step four, scolomization. You know what it means. We eliminate the existential quantifiers, so finally we will get a formula which contains only universal quantifiers. Okay, so we have to eliminate all the existential quantifiers. Let's remove the first one. This quantifier is located at the very beginning of the formula. This means we can substitute y with a new Scolem constant. Let it be c. And then let's remove the other existential quantifier, x is v. This is also located at the very beginning of the formula, so we can substitute V with another Skolem constant, for instance, D. Okay, step 4 is done. We have a formula with which is only quantified by universal quantifiers. Now, we translate the scope of the quantifiers, which is denoted by A here, to CNF. At this point, this only means to the need, it can only mean the need of applying the laws of distributivity. So let's check out the scope of the quantifier here. This is what we need to translate to CNF by applying the laws of distributivity. So this is what we get for all Z, and then the first clause is going to be RDC or RCX, and the other clause is coming, not RDC or RZZ. Okay, this formula is already in CNF, but not really, because we have one more duty. We have to split the formula into clauses. This means that basically we have to propagate this quantifier prefix into each of the clauses. That is, we have to copy this quantifier in front of the second clause, and of course we also have to close this quantifier here. No, we just need to remove one of the parentheses here and there. Okay, this formula is in CNF already. There is an optional step, simplifications. Whenever we can, then we should apply simplifications anytime, as it is written at the very bottom. Simplifications also cover the elimination of unnecessary quantifiers. And now we have two quantifiers, and as you can see, one of them is unnecessary, the first one. This quantifier is unnecessary because Z has no occurrence in the scope of this quantifier. Therefore, we can simply remove the first quantifier. So this is the result of applying this algorithm. As you can see, it highly simplifies the translation to CNF if you know this algorithm. This is why we suggest you to run this algorithm whenever you need to translate a first order formula to CNF.